Multiplying and dividing powers with the same base. So these are your notes. I want you to look at the first one. It is multiplying. This is 4 squared times 4 cubed. Now, I want you to know that 4 squared does not mean 4 times 2. It does not mean 4 times 2. That would be 8. This is actually 4 times itself twice. So it's like saying 4 times 4. Okay, that's the first 4 squared. The 4 cubed is saying 4 times itself 3 times. So it's like saying 4 times 4 times 4. All right, so what I want you to know is we have 2 4s and then we have 3 4s, and they're all getting multiplied, not added. They're all getting multiplied. So I want you to know that if we have 4 squared and 4 to the third, that is a total of 1, 2, 3, 4, 5 4s. So how you write that is 4 to the 5th power. Now, if I were to solve this, that would mean 4 times 4 times 4 times 4 times 4. But we don't need to solve it today. All I want you to do is write what it would be as far as an exponent. So since these two numbers have the same base, bases are the numbers that is the whole number, not the exponent, but the whole number. They have the same base, which means we can add their exponents. See how I did that? You could take 2 plus 3 to get 5. So that's your shortcut. If numbers have the same base, you may add their exponents. So what pattern do you see? Here's the pattern or the rule. When multiplying numbers with the same base. Oops, sorry, can't see that. With the same base, add their exponents. Okay, so when the numbers have the same base. So now let me give you a quick example, just somewhere in your notes you can write this. If we have 3 squared times 4 squared, you can't just say, oh, well, that will be something to the 4th power. These are not the same base, so it won't work. The only way it will work is if our numbers are the same base. So it's like the same 4 times 4. That's the only way you can add their exponents. Okay, so let's go ahead and try a few. This is a good time to push pause and try these first 2 on your own. If you're not quite ready to pause and try your own, these have the same base. So we're going to keep the base 3, and we're going to add 2 plus 2, which is 4. Okay, on this one might have been tricky for you. If there's 2 to the nothing, it is a hidden invisible 1. So actually the base is 2, but it's 1 plus 3 plus 4. So 1 plus 3 plus 4 is actually 8. So I'm afraid if you tried this on your own, you might have put 2 to the 7th, but that's because I hadn't mentioned yet that if there is nothing, no exponent, it's a hidden invisible 1 exponent. Because if it was 0, if it didn't count, it wouldn't even be there at all. It would just look like this. But it's there, so there's 1 of them there. Okay, the next ones we need to do together. So here's an example kind of like I crossed out up here. They are not the same base. When they are not the same base, you can go ahead and multiply them. So we're going to multiply 2 times 5. I'm not talking about the ends, and I'm not talking about the exponents. Only the 2 times 5. So 2 times 5 is 10. Now, what is the same base? We have an n to the 4th that's the same base as an n to the 5th. So those can get added, their exponents. So n is the base, and 4 plus 5 is 9. Okay, so do you see what I did there? I multiplied the numbers that are not the same base, and then the ones that are the same base, I used their exponents to add. All right, so knowing that, you could try these bottom 3 on your own, or if you're not quite ready for that, I'll work it out with you right now. So the 7 and the 10 and the 8 are not the same bases. Those are different bases. So I can go ahead and multiply them together. 7 times 10 times 8. I'm going to use my calculator. You guys should too. 7 times 10 times 8 is 560. So we have I'm going to write it down here, 560. Now let's look at what bases are the same that we can add. This one doesn't have any u's. This one does. U to the third and u to the nothing, which means 1. So 3 plus 1 is 4, so it's going to be u to the fourth, and then v to the fifth and v to the third. Oh, and I forgot the v to the third at the beginning. So these v's are all the same base, so they can get added. 3 plus 5 is 8, plus 3 is 11, so v to the 11th. There you go. All right, let's look at the next one. 8 and 9 are different bases, so let's go ahead and multiply them and get that out of the way. I think 8 times 9 is 72. Double check on your calculator if you're not sure. And then we've got m to the third, that's the same base as m squared. 3 plus 2 is 5, so m to the fifth. And then we've got n to the third, which is the same base as another n to the third, which when you add that, that would be n to the sixth. All right, let's look at this last one. There's no whole number out here. It would be the same thing as a 1, or you could just ignore it. So the only whole number we have is 4, so 4 times 1, or just 4 itself, is just going to be 4. But then let's look at the a's. This a doesn't have an exponent, so that means it's a hidden invisible 1. This a also doesn't have an exponent, so that means it's another 1. So a and a is going to be a squared. And then you've got your b to the hidden invisible 1 and b to the fifth, which would mean b to the sixth. Okay, if I'm talking too fast or if I'm explaining this too fast, please go back and rewatch so that you understand all of this. All right, the next skill you guys are learning today is about dividing. So dividing kind of works in the same way as multiplying, except opposites. We're going to have a rule when multiplying numbers with the same base, but down here it's going to be when dividing numbers with the same base. Let's see what happens. So here's what I want you guys to see. I want you to see that 4 to the fifth, if I wrote it out, if I expanded it, if I used expanded notation is what it's called to expand it, it would mean 4 times 4 times 4 times 4 times 4. See how there's 5 of them? 1, 2, 3, 4, 5. And on the bottom, or divided by, I have 4 to the third power, which means there are 3 of them. So here's what happens. When you're dividing a number by itself, let's just do one of them. Let's just say 4 divided by 4, because it's a fraction. So 4 divided by 4. 4 divided by 4 is 1. Anything divided by itself is the same thing as 1. And a lot of times you know that 1 stays kind of hidden and visible. So if we have a 4 up here and down here, we can cancel them out because they would just be 1. So I'm going to go ahead and cancel another pair out because 4 divided by 4 here would also be 1. And I'm going to do it one more time. And so what do we have left? What we have left is just this on the top, which would just be 4 times 4. So if there's only 2 of them, 4 times 4, if there's only 2 of them, that means it's 4 squared. That's supposed to be a box for an exponent. So the final answer is 4 squared. Now an easier way to do that is if we are dividing numbers with the same base. See how this is a 4 and this is a 4? What could we have done with their exponents to get here a lot quicker than doing all this cancel, 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 cancel junk? I hope you see that we could have gotten 4 squared by just taking our exponents and subtracting them. So here's the rule or the pattern. When dividing numbers with the same base, remember, they have to have the same base. With the same base. You can't do it with numbers that are different. It has to be numbers with the same base. So when dividing numbers with the same base, subtract their exponents. Okay, so that's the rule. When you're multiplying, you add the exponents. When you're dividing, you subtract the exponents. Remember, it's only if the numbers have the same base. So let's look at a few examples. 5 to the fourth divided by 5 to the nothing, which means there's a 1 there. So if we're going to subtract, because they're both 5s, they both have the same base, 5, then 5 is going to stay the base for the answer, and 4 minus 1 is 3. All right, let's try another one. This is going to be interesting. Okay, 2 and 2. 2 divided by 2 is going to be the same base, so our answer is going to be 2. But let's look at our exponent. What is 2 minus 3? 2 minus 3. 2 minus 3 is negative 1. So we're actually going to, for today, leave it negative 1, but you're not going to end up leaving it like that for long. But this is for another lesson, another day. So for now, you're still subtracting. It's still negative 1. We're going to leave it like that. But normally, we will not have negative exponents. But again, I'll talk to you about that later. Okay. I'm sorry to say that these are not the same base. So you would divide them, or you know what? Let's just leave it 3 over 2. If they're not the same base, you can't do anything with them. However, the r's are the same base, so we can subtract those exponents. There's a hidden invisible 1 here. So r to the third minus r to the 1 is r squared. Okay? If you went ahead and divided 3 over 2, it'd be like 1.5. So if you put 1.5 r squared, that's the same thing. I would accept this also. Okay. 10 divided by 6. 10 and 6 do not divide evenly, but they do simplify. You can divide them both by 2, can't you? 10 divided by 2 is 5. 6 divided by 2 is 3. So let's simplify it. If you can simplify it, let's do. And then these two are the same base. So p to the 4th over p to the hidden invisible 1 means we're going to subtract. 4 minus 1 is 3. So it would be p to the 3rd. And there's no more on the bottom. Remember, if we expanded these, if we put 4 on the top and the 1 on the bottom, it would cancel out. And it would leave none on the bottom, which is why I don't have any down here. And it would leave 3 on the top, which is why I put p to the 3rd on the top. Okay, 12 tenths. This also does not divide evenly, but it does simplify. They'll both divide evenly by 2, 12 and 10. 12 divided by 2 is 6. 10 divided by 2 is 5. And now let's look at what we can simplify. We can simplify the x's. X and x are the same base. So 4, you can subtract 8 from it. 4 minus 8. 4 minus 8, oops, again is negative. So it's negative 4, so it's going to be x to the negative 4th. For now, we're just going to leave it negative, but you will not leave it after another lesson soon. Let's look at the y's. 1 and 1, hidden invisible. 1 minus 1 is 0. If there are 0 y's, then there's 0 reason to write a y. They're gone. They completely cancel out. Remember, they cancel off the top and bottom. If there's the same thing above and below, they cancel out. So this is actually done. All right, last one of these. Well, it's not numbered. It's the last one. 5/20 does not divide, but it does simplify. They can both divide evenly by 5. So 5 divided by 5 is going to just be 1. 20 divided by 5 is 4. And now let's look at our ends. If I expanded this and had 8 ends over another 8 ends, they would each end up canceling out. So that would leave no ends. So we don't even need any ends. 8 minus 8 is 0, which means they're gone. So all you have is 1/4. Okay, let's turn it over to the back. And this is really practice for you, so I would love to see you push pause on the video and try all 6 of these on your own. If you're just not ready, I will work them out with you, but if you are ready, I'd love to see you just fast forward and check your answer with mine after you try them all on your own. Okay, again, if you're not quite ready, if these numbers are being multiplied and they are not the same base, you go ahead and multiply them. So 6 times 2 is 12. The x and the x are the same bases, so they can get added. So 1 plus 2 is x to the 3rd. All right, these are being divided, and remember, you can only subtract when you divide if they are the same base. So the x's are the same base. That is going to be 2 minus 1, which is x to the 1. Now I'm going to leave it invisible. 2 minus 1 is 1. Remember, 1s are invisible. So I'm just going to assume that there's a 1 there, but not write it. The y to the 5th over y to the 3rd. 5 minus 3 is 2. So that would be y squared. Okay, the third one. These are not the same base, so you can divide them, but they don't divide evenly, so I'm just going to simplify them. They do both divide evenly by 2. So 18 divided by 2 is 9. 10 divided by 2 is 5. And now I'm going to look at my bases that are the same. X to the 8th over x to the 3rd. 8 minus 3 is 5. There would be 5 left on top if I expanded this. So that would be x to the 5th. And then y doesn't have any other y. So it's just going to stay y to the 8th, but it needs to stay up top. So if there's nothing you can do, then it just stays put. Okay, the next one. These bases are not the same, so you can go ahead and multiply them to get rid of them. 7 times 9 I think is 63. You might want to check your calculator. U squared can get added with this one u that's hidden invisible, so that would be u to the 3rd. And then the v's, there's 5 there and 3 more there, so that would be v to the 8th. This second to last one, these can get multiplied. 10 times 8 is 80. And then the x's can get added because they're the same base. That's a hidden invisible 1 and another hidden invisible 1, so that is 2 of them. And then you've got 3 y's and 3 more y's, which is 6 y's. All right, last one. 12 and 9 do not divide evenly, but they can simplify. They will both divide evenly by 3. So 12 divided by 3 is 4. 9 divided by 3 is 3. And this is an x and that's a y. So guess what? These are not the same bases. So you can't simplify them by subtracting at all. So it's just going to stay x to the 3rd up top, and it's just going to stay y to the 8th down on the bottom.